Hey everybody! Welcome to the second week of online learning. This week we'll learn 10.5. We'll do several review activities and then you'll take your test. So ending the week with a bang before spring break. So, one little memo before we get started. This is my birthday hat. Can you see it? Oh wait, I gotta tilt this way. It's my birthday this week, so say happy birthday if you think of it on Wednesday. All right, so 10.5 is formulas of hydrates. I'm going to have you guys read 351, 352, and 354. Notice I skipped a page. That's because some of the math we're skipping in this section. So I want you to mostly know the vocab term and how to name hydrates, and we'll be good to go for reviewing for the test, and that's how we'll spend the rest of our week. All right, let's define hydrates. They are solid ionic compounds in which water molecules are trapped. And if you remember the definition of a crystal lattice from a prior chapter is the idea that three-dimensional geometric arrangement of particles. Well, now that we have hydrates, we have water trapped in that crystal of a substance. And so water molecules here are going to be treated as a separate unit because they're not actually covalently bonded with the chemical. They're just there in the crystal lattice structure. So we got to get to naming these and then we'll be ready to go. So here's our first example. Calcium chloride dihydrate. We have the formula here on the left, calcium chloride. And for one molecule of calcium chloride, there'll be 2 molecules of water, dihydrate. So we are definitely using our prefixes for the water molecule to indicate how many water molecules there are. Calcium chloride di reminds you that there's 2 waters. Hydrate is another word for water. So it's as simple as that. Seems pretty easy. You do need a little bit of practice though, so here are some more problems to try out. And I move this up a little bit so we're not running into the camera. Go ahead and pause and try these problems out following the example of the first one. And the answers. Let's look at these closely. When we have a prefix like 3, that's tri. 10 is deca. Notice that all of these are hydrates and they all end in hydrate, with the prefix indicating how many waters are in the formula. Notice we have some naming rules to practice again. So calcium chloride, you had to know to dance that. And sodium acetate, you had to remember your polyatomic ion acetate is our CHO 232. So a couple things that you'll want to just brush up on and be fresh with going into your test. Knowing some of these naming techniques. Other than that, it is pretty simple and pretty straightforward, I think, as long as you kind of understand the patterns that go on with hydrates. So with that, I'll leave you with one more thought, which is that you're going to do a little ed puzzle with a lab. So I wanted to quickly go over the calculations that you'll be doing with that lab activity. So this lab activity basically involves a dish that can be heated up to high temperatures without breaking, and we put some of our hydrate in the dish. If you heat it up with a flame, the water steams off, leaving behind just the chemical itself, and theoretically all the water, if you heat it for long enough, disappears into the atmosphere. So some of the math involved in this that you'll see in the ed puzzle and that you might see a calculation with on your test is, let's suppose that the mass of our hydrate is about, let's say 4 grams. But after we heated the material, let's say the mass of our hydrate turned into, let's just say 2.5 grams. You take the difference between those, we have to imply then that the mass of the water was 1.5 grams, which boiled off because that is the mass that is missing from your 4 grams going to your 2.5 grams. So well, that's a terrible 1.5. Let me try that again. 1.5 grams then is missing.